Oh, hello. My name is Chris Fernandez. Today I'm going to be showing you how we're going to use NetPlay to create a very precise and kind of time independent type of impairment using NetPlay. What NetPlay does, it's you can actually classify what are the explicit scenario or impairment that you're going to be doing at a per packet level. So just as an example here, I have, for example, this is the first thing we're going to look at is our topology, right? So our topology here is we're going to pretend that we have a central compute node in the car and we're talking to the back of the car. So the back of the car has the left side network and the right side network. So the left side network has a MAC address of Facebook, right? So Facebook using zeros and ones, and the right side of the car has the coffee as a MAC address. So just to identify the right and the left side here of the car. And in terms of traffic, I'm gonna using a specific traffic. So I'm saying that each zone with left and right, it's gonna be using 50,000 packets per second, and I'm gonna be sending traffic for 10 seconds from each zone. So just in case here, so just to make sure that everything is working as is before we introduce any type of impairment, I'm just going to send this traffic here. The traffic is going to run for 10 seconds and it's going to end. So the traffic is being applied. I can show you here. So you have the back left side and back right side coming from, so it's coming on my scenario here is coming from the back to the central compute. So it's going from right to left, right, in this case here. So I'm just going to send traffic as is. We can take a look at it, the traffic as it's going. So I'm going to send the traffic in, and it's going to be using those MAC addresses here as this is just a simple layer 2 traffic, right? In this case here, this cloud here represents my network emulator 2 ports, right? So as you can see here, I'm sending packets frame 50,000 packets per second for only 10 seconds, which is going to generate me 500,000 packets from the left side and another 500 packets from the right side. I don't have the correct item here. Is just a matter of editing the traffic item name. But at least the left side is here, so you know what it is. At this point here, you can see everything worked. I can see that my packets, all the packets are sent and received, and you can see here that my latency is between 12,000 to 13,000 nanoseconds. The packets itself, I think it's 110 by packet. It doesn't really matter much because I'm just sending a specific traffic, right? Now, let's go back and introduce the latency here in NetPlay and how that's going to work, right? So, in order for you to understand NetPlay, NetPlay runs on the channels. So you have to kind of specify each packet what it's going to do, and I'm going to add the specific scenario to a specific side of the car, right? So let's say that I'm going to interfere on the left side of the car here. So the left side of the car is using the Facebook MAC address, right? So inside here, I'm going to go into my profiles, and I'm going to create this left profile here. It says the left zone. So the left zone, and the filter here is based on the Facebook MAC address, right? So all the MAC addresses, the source MAC addresses of the traffic coming that has 02 Facebook as a source address is going to be is going to be filtered by this profile here, right? So if I want to see that working, I can see here. Let me clear everything here and do it again, and do the traffic again, so we can take a look. So let me reset the stats here. So the resets for this. So what I'm expecting is that port number 2 here is connected to my right side of the car, right? So I'm expecting that 500,000 packets are going to hit this left zone here, and another 500,000 is going to hit the default, which is I don't have any other traffic filter on that, right? So if I send this traffic again, I'm going to take a look at my statistics here working. As you can see here, the left side is correct, figuring out that I have 50,000 packets per second coming in, and it should accumulate to 500,000 evenly, right? So this here captures the left side of the car, and the default now captures the other side, right? So the other side. So everything that does not get captured by the default goes into the default. So everything is working as is. So I am capturing the traffic that I want to interfere with. Now, for the interference case, what I want to do is to create a scenario where I don't care about the synchronization. So let's say I'm sending packets at 50,000 packets per second. So at 1 second, I have 100,000 packets and 200 and so on, right? So what I want to do, I want to send traffic for 10 seconds. And the way I want to interfere is I'm using a Python code here to generate the traffic or to generate the impairment that I want, because I need to write 500,000 lines of code, one for each packet individually, right? And the way that the NetPlay works is that I'm going to create a file here that I can show you in a minute here, where its total packets is 500,000, right? So the first 325,000 packets is normal count, meaning nothing's happening, everything is flowing through, no problem. And then a jitter counts. This here is like when you are in a crash situation, or when you're trying to simulate something that is about to happen that is bad. The first thing you see, the anomaly that you see on that network, on that side of the network, will be, for example, jitter, right? So I'm going to do is for the next between 320,000 packet and the packet number 350, I guess, I'm going to just add 50,000. I'm going to add just a little bit of latency to it. Just another, I'm going to write, and I'm going to add some latency to it, just 50 microsecond of latency, showing that it's a brownout zone, right? Something is happening on that zone, but nothing really happened yet. And then after that, after the 350 went by, I'm going to drop the rest of the packets, right? So this here will generate a file that is very, it's long, but it gives you the ability to individually per packet say what you want to do with it, and being very independent of any automation, right? So when I first tried to solve this problem, I was doing some Python, and I was trying to calculate how long it takes for you to send a request message and getting back, and how long it would take that for the FPGA to be programmed. So it's not, in terms of, it's not as precise as this one. It's not as easy to implement as this the NetPlay is. The NetPlay, there's specific stuff that you need to write on the test. So that's what this Python code here helps me to do, is just to write that file, and that file looks like this. Let's see here. It looks like this. It's a 500,000 file long, because it's for every packet. So what it's saying here is, for this packet, do nothing, add nothing, right? So add and drop is nothing here, right? So if I want to add a delay, I'm adding a delay to 500 at 325,001 packet. And so I don't know if this is even there, but yeah, so over here at 325,000 packet, I'm going to introduce the one, right? The 50, I think it's a 50 microsecond of delay, right? So this is happening here, and I kind of write, so this packet, I'm introducing the latency, and then at some point here, between, I guess at 350, I'm going to start dropping everything, right? So that's at 350, that's where my point of, okay, I'm done, I'm going to be 350. 350 is the transition between the zone that I was complaining about something is happening and actually happened, right? So at 3050 that happened. Let's see here. So this is 325. Anyway, you got the point. So after I create this file here, I'm gonna go into my channels, and then on my channel I'm gonna select NetPlay. I'm gonna say where I want this NetPlay to be at. I'm gonna attach this to that filter, right? For the filter that is just for that zone, that grabs just packets from that zone. So I have traffic coming in from both sides, from the left and the right, but the right side is not going to be affected, so I'm just affecting the left side. I'm saying here is the change every is what to do for every line of code that's coming in on that file, right? So, and then this is just a label, and the NetPlay count is how many times I'm going to be executing this, right? So this is just one. It's just going to go through the file once, right? That file has 500,000 lines of code. So you're just going to use that. And here's the buffer. The buffer is how much of the buffer I'm using to get this working. Because this file is kind of big, but as you can see here, I still have a lot of buffer left. And if you look at my profiles here, this little memory indicator here is kind of telling me about buffer size. So if you need to get more buffer into a particular, if you need to add more buffer, that's how you kind of manage it and so on. And I mean, it's kind of beyond the scope of this presentation here, but just be aware that we can manipulate the buffer if we have a bigger packet size or a bigger buffer that we need to allocate. So at this point here, I'm going to go into my channels again. So I loaded that file. So this is the file that I got loaded. This got selected, and now I can start select. So now what's going to happen here is when I start select here, this is going to start looking at the packets that are coming in. There's nothing coming in now. So this is the beauty about not having to synchronize when you hit the clock, when you hit the start traffic, and so on, right? So at this point here, I'm going to go back to my network, and I'm going to send that traffic again. And at this time, I'm expecting that the back left source here should have 150 packets lost, and I should expect to see the latency for going to 50,000, because I did introduce latency for a few packets, right? So there it is. So you can see that I lost 30% precisely. And also let's go now check into my latency. So I'm seeing that the max latency here should be 50,000, which was the latency that I introduced. So I did not drop those packets. I just introduced latency to see that something is happening to that side of the car, but it's still kind of working, and then it failed completely after, right? So this is what the simulation did. And that's what you can see here, the result of it. About this, the NetPlay here, which is really cool, is that you can do this manipulation per packet, and it's very precise. So every packet comes in. There are some restrictions in terms of what you can do, but it works well for this type of scenario. So if I stop selected here, there's some stuff that I can do here and actually configured here. So if I want to, even though there's drops in there, I just say don't delete that part of the profile, and that's it. The delay as well. There's here, as you can see, there's delay of the packet that's in there. I can say don't do whatever it's in that file there, or add something to it. Now when this is running, let me see here. I'm going to start this again here. When you go back to profiles, the port 2, and you're gonna see under impairments, you see here that the NetPlay is the one that is using that. So I cannot add anything to this right now because the NetPlay is the one that is this port is using it for. So it's very precise, and you can do this over and over again and repeat, and it's going to be always the same result. So at this time here, I can actually what I can do is capture some here so we can take a look. I don't know if I missed everything here. The stack capturing is kind of too late. Let's see if I have enough to at least give us an idea what happened here. I have 100 and I have pretty good chunk of packets here. This here corresponds to 1,000,000, so that 1,000,000 packets because there's coming from both ends. You can see here, we'll take a look. As you can see here, I have packets coming in from both, right? From the Facebook side and the coffee side. If I want to just do the, let's see. At this point here, I didn't catch any packets coming from the other side. It was too late. So I can actually do it again. So we can take a look on the wire here. The NetPlay is still going, right? I didn't change anything here, so that's still the case. So I'm gonna do it again, send the traffic again, and I should be getting 1,000,000 packets this time. And then we can take a look what happened in the wire itself. It's only 10 seconds. So it's going to run for 10 seconds. It's going to collect 1,000,000 packets coming from both sides. And we are, let's see, traffic stopped. So I stopped this. And 1,000,000 packets got captured at this time. It's going to take a while now because this is a long buffer. It's still at 100,000. See, we can start looking at it. I only want to see packets from face. So if I got it in statistics and graphs. I'll let it, it's still at 200,000 trying to read. So it's kind of still going. But you get the point. So let me know if you have any questions about it. But this is it's a very precise way of doing impairments per packet. You can read more about the restrictions there are on using NetPlay. But in terms of implementation for networks, there are not synchronized to what we're impairment trying to do, so we can impair at per packet level. I think it's a very interesting idea. So let me know what you think. If you have any questions, of course, reach out and we can go over again. All right, thank you. Bye.